Welcome to Memfault's launch week. It is my honor and privilege to be sharing with you what we've been working on for the past few months. After the launch of Device Vitals last quarter, we went right back to work and we challenged ourselves to do even better. I think we've done it. You're going to be the judge. I'm going to present to you what it is we've been building, why we think it's important, how you might use it, and of course, I'm going to give you a demo. But first, a few notes on Memfault and on building devices in general. Many of you know that building embedded devices is hard. First, it's hard because the devices themselves are constrained. This is not a cloud server where you have infinite memory, bandwidth, power, and storage. These devices are compute and storage constraints. They have small chips on them that are oftentimes optimized down to the kilobytes in order to save costs. They're intermittently connected over all kinds of protocols. Sometimes you've got IP, like when you're on an LTE connection. Sometimes you're just sending packets with a bunch of bytes in them and rolling out your own protocols on top of it, like if you're connected over BLE. These devices are power constraints, they're cost constraints. And as an engineer, you've got to take all of those constraints into considerations as you design ever more interactive and exciting experiences. And if that wasn't enough, these devices are in extremely difficult environments. Here again, this is very different from where most software operates. Embedded devices might be outdoors, they're in people's homes, they can be connected to routers that themselves have their own software and environmental problems. They're in the hands of users who never quite do what you expect them to. And so this combination of constraints and diversity of environments and the unknowability of the environment makes for a very tough engineering challenge indeed. And that makes building the devices hard enough. Making it reliable is especially challenging. During the development cycle of our devices, which on average from our surveys takes about 16 months, we work really hard to try to anticipate all the ways they'll be used, all the environments in which they'll be deployed. But of course, we don't know. And in fact, because these devices are in the world for 8 years on average, not only do we not know, but things can change over time. What might have been a reasonable set of expectations at the beginning might be very different 8 years later. New technologies might have emerged, new protocols, new spectrum might have been made available close to the spectrum you're using, which all of a sudden interferes with your device. And because we don't have good tools, oftentimes we have no visibility. We don't know what happens once the device is in the field. So we spend those 16 months working hard in the lab to test every possible contingency. And in the end, we just hope that it goes well. That, of course, doesn't work super well. And as a result, IoT devices oftentimes have a reliability challenge. I often tell the story of a old school hardware lock, a lock that you might have on your home when you turn the key in the lock, it unlocks every time. You never think of it. But when you have a connected lock, if you press the button in the app, there are so many ways that things can go wrong, like connectivity, the software itself. It's endless. At Memfault, we believe that software, while a challenge, is also a huge opportunity. We're on a mission to make software the most reliable part of the IoT. And in fact, we believe software can not just itself be reliable, but it can make the devices themselves more reliable, because we can start detecting the behavior of the hardware and we can do things like predictive maintenance. We can understand better under what conditions the hardware fails. We can understand the environment better and make better products over time. And so you know that with Memfault, we've given you tools to make really reliable products using the power of observability, that is collecting data from the devices to understand their performance, and to get to the bottom of problems when they emerge. But as you know, there's a difference between a reliable product and a great product. A reliable product is a product that does what it is designed to do. In other words, it works the way that it's supposed to work, the way you've designed it. But a great product is a product that works the way the customers expect, a product that does what customers want it to do. That goes beyond the design intent. A great product has understand what its users want and need. In other words, reliability is about understanding how it works, but building great products requires understanding how it's used. And so we've built the first platform that can answer both of these questions. Today, I'm excited to launch Product Analytics by Memfault. So you can find out what is happening with your devices after launch and build better products. In conjunction with Memfault's great features that you already know, you can finally build not just reliable products, but great products by understanding how it's used and how it works. For the first time, embedded device makers can get real data to answer important questions. With product analytics, you can track product engagement and adoption. You can know whether your product is being used all the time, sometimes, or never. You can monitor and analyze feature usage patterns and behavior. You can know when your users use what features in conjunction with what other features, and start understanding where you should be investing more energy as you think about improving your products or building your roadmap. And you can also correlate feature usage with device performance and reliability. This is key because product analytics is not a separate product. It's not a separate set of capability from Memfault's reliability products. Product analytics actually enhances the whole. Together, reliability features and analytics features are greater than the sum of the parts, and they let you answer really complex questions that we'll get into a little bit further in these presentations. Like all Memfault products, product analytics is optimized, and even it is built purposefully for embedded devices. It's a simple integration that collects data from the device itself. It works across all operating systems, whether you're running an RTOS or even bare metal on a Mac controller, or you're running Android or Linux on a larger SoC. It can use any connectivity path, and in fact, we can even collect data while the device is not connected for intermittently connected devices. Whether it's Bluetooth, Wi-Fi, LTE, satellite connectivity, you can collect data with product analytics and get those insights with Memfault. Last but not least, the Memfault SDK is compute, power, and bandwidth efficient. So you can trust that the tools you are using to make sure your products works best do not themselves impact the behavior of your products. So why should you care? First, because today there are huge gaps in your data. Most of the dashboards you're looking at today are driven by your web or your mobile data. We see many companies that do this. They instrument the cloud, they instrument their mobile gateways, and then looking at the data that goes through the cloud and the gateways, they try to guess what the device might be doing based on what the endpoints see. In other words, I like to say they look at the shadow of the device that they can see from the vantage point of the mobile app, and then hopefully understand what the device itself is doing. And for some users, this may work well enough. For example, on the left here, I have user one. They use their device. It's a BLE device in this example, that they use it while running. And they take their phone with us. So the wearable is constantly connected to the phone. So we know what that user does pretty well by just looking at phone data. But consider user two. who prefers to run without their phone? Most likely, we have very little data about that user. So big gaps. Wouldn't it be nice to get the data from the device itself? Ultimately, that's the source of truth. The second reason you should care is because your users will never cease to surprise you. Here's an example. So here again, we're thinking about a fitness wearable, a BLE device. You're wearing it on your wrist. It tracks your steps. It tracks your workouts. I think you've all seen devices like that. And the design team has made it waterproof so they can be used while swimming. They also have, this seems unrelated, but you'll see where I'm going with this. They also have designed it to have a battery that lasts 3.5 days. We tested it in the lab. It lasts 3.5 days, and we advertised 3 days. So that's what the user expects. Except where we expected it to be used was here at the beach, great weather. We've tested in all those environments. And it turns out in the real world, this is where our users are using it. And of course, we know that temperature has a huge impact on battery performance. And so all of a sudden, our users are getting 1.5 days of battery life, and they're complaining. They're not using it wrong. We just didn't anticipate it. And if we don't have the data, if we're not getting data from the device, we may actually not know that this user is experiencing this low battery life. And we may not know that the device is being used in this new context. The third reason you should care is because no amount of guessing will ever get close to real-world data. We have 16 months to guess how the product will be used. And then over those 8 years, it's used in all kinds of ways, new ways every day. So in order to know how our product is actually used, we need data during those 8 years. We can't just rely on guessing. With product analytics, you can, for the first time, get that data. And you can understand from the device itself how it's being used. Here are example questions that you could answer. Here again, in the context of this fitness wearable, we could answer, when are voice commands most often used? And which types of workouts are most likely to see voice commands used? You can imagine that users may not use voice commands while swimming, but they may use them while running. Or we can say, how many words are used in the average voice commands? And does this change based on context? This may be important as we optimize the size of the buffers that save the voice command data. We can ask, in what percentage of workouts is the device connected to a phone? Does this vary by workout type? You can see already that the ability to ask question and then also slice and dice the data by activity or by underlying type of use can be really interesting. And getting that data straight from the device, straight from the horse's mouth, is critical. Product analytics also bring us a new level of understanding around reliability. Because we collect usage data, we can actually understand performance even better. It makes Memfault better than ever. Here again, some example questions we might want to answer. How do voice commands impact battery performance? We have our lab model, but how does it actually work out in the field? How often do voice commands fail? And is it correlated to the length of the voice command? How many words are used? How often does the device attempt to connect to a phone and fail? And are there any environmental factors that influence that failure rate? These are really, really interesting questions. And most of the teams we talk to today do not have the capability to answer them. We're in a unique position to connect the dots between usage and reliability. For example, you might already know how often does this feature is used, or which of my feature is least popular, or how frequently do these features get used in combination. But what about how does usage of that feature impact battery life? Or are people using this feature less because it's unreliable or because it's causing other problems? Is it because they don't want it or is it because it doesn't work? Um, and when they use features together, are they actually performing as expected or might they interact in a way that causes more problems? This is never before seen capability, and it will help you make better decisions and build better products. This means higher performing products. It means better customer experiences because you'll actually be able to see what the customer is experiencing. It means more efficient teams because your teams don't have to spend nearly as much time guessing or trying to reproduce problem or flying to the customer sites to understand how it's being used. With product analytics, Memfault brings together all of the tools that you need to develop your products in one platform with a single SDK to integrate. A single SDK, one integration, and you're done. It lets you create a virtuous cycle of improving quality, right? With performance monitoring, you might find performance issues. With our debugging product, you will fix it. With product analytics, you will see how it's used and improve not just the performance, but the usability of it. And with Memfault OTA, you will ship those updates and continuously improve your products. You can do all this with our rock solid infrastructure, which you do not need to maintain yourself. We maintain it, we scale it, so you can focus on what differentiates your business. Memfault also brings together your entire development team in one platform. Engineers, of course, use it to fix problems and understand the top issues impacting the fleet. But also QA teams use it so they can triage and prioritize issues. Product managers use it to look at product analytics. Customer support uses it to pull up devices customers are complaining about and get real data about what those devices were doing at the time. This is all this data and all this collaboration is happening in one place under a single pane of glass with collaborative features built in so that your users can help each other do their best work. So with all that in mind, let's see it in action. All right, let's take a look. So here I've loaded up the Memfault app. Many of you already know it well. We're looking at the overview dashboard, which shows how many active devices are seen by the platform, what software versions they're running, what issues are in the fleet. Of course, this dashboard can be edited. You can add cards, reorder cards, change the size of cards, everything you'd expect from a dashboard product. And because we're talking about product analytics today, we've created a specific product analytics dashboard, which we're going to look at. So let's click on it. Okay. So here in the context of this demo, we've built data, assuming the device looks a lot like the one I've been talking about during the presentation. This is a fitness tracker. It can record your steps. It can record your workouts. It accepts voice commands. And it's connected over Bluetooth. And of course, we've been using Memfault to look at the reliability data using Memfault's observability features for this device already. But now we've got some product analytics data. Let's see what it looks like. At the top, we see the active devices, the active users, and exercising users. In effect, it's how many devices are online, how many are being used, and how many of those devices are being used for our most important feature, the workout tracking feature. And we've used Memfault's product analytics features to create these charts. So for the active devices chart, it's quite simple. We're just looking at all the devices that have phone home for any kind of reason. Some of them might have just checked in for a software update. Others might have sent some usage data. Others might have just sent an hourly heartbeat. They're not necessarily in active use, but they're online. Number two are active user counts. So that ends up being specific from device to device. So how do we define an active user for our fitness tracker? Well, we decided to go with any user that recorded at least one step that day with the device, because that's kind of the simplest function of the device. And here again, we were able to create a chart where we did a roll up over time of all the devices that saw at least one step in their hourly metrics reports. And then last but not least, looking at our most important features, recording workouts and exercising, we basically created a roll-up of all the users who did at least all the devices that recorded at least one workout of any kinds. That can be, this device does swimming, running, and a few other types of workout. This is the roll-up of all the devices that saw at least one of those workouts in the day. And as you expect, there's fewer of each of those as we go down the funnel. So we have 598 of these active devices on June 23rd, yesterday. We have 246 of those that actually are active users, and 149 of those that are seeing exercises. So there's opportunity to improve that. By the way, we displayed this as separate charts, but with Memfault, you can also display it as a funnel. So here, what I did is looked at this adoption funnel on a daily basis, and you can see, a steep drop off. This is much easier to see visually, a steep drop off between your active devices and your active users. And that's where, if I was a product manager, I would focus most of my effort. There's a lot of, active users to be stimulated back there. Let's scroll down and look at what else we can see with Memfault. So here at the in the middle, I can see my voice command usage. So voice command is a feature that we just shipped on this device. On June 14th, we shipped voice commands. So you can see, of course, that there was no usage before that. And the first chart we look at is just the total number of voice commands being used. So you see 0 on the 13th, and then we start users starting to use our voice commands. There were 223 voice commands sent over on June 13th. This is about, on average, almost one voice command per active user. Seems pretty good. Of course, there might be some heavy users that send a lot of them, and we can, of course, dig into that data further. Further down, we looked at how many of those are actually successful, because our voice commands, we've noticed, fail sometimes. It can be because the device is not connected, but it can be for other reasons as well. And here we see that, for example, on the 23rd again, we had 180 commands that were used successfully and 43 that failed. So that's a pretty high failure rate, about 20%. There's something to look into here. I'll actually go and edit this chart. And I'm going to add a segment. So here we have two segments, successful and unsuccessful voice commands. I'm going to add a segment for the unsuccessful voice commands where the device was connected, which means that the connectivity wasn't the issue. So I'll click Add Segment. I'll select my voice command report type, and I'll add two conditions. Number one, the voice command was not successful. So success is 0. And connected was not 0. So the device was actually connected. I see a preview of my chart here in the top right, and I can press OK to save it. And now we can see that actually most of our failures are while the device is connected. So there's probably a software bug somewhere we'll want to look into. Scrolling further down, we can actually see some really interesting data, which is now looking at voice commands while in a workout. So this is where, the power of this tool becomes evident, right? Like, we're now slicing the data about one of our features, and basically looking at it in the context of other feature usage. So first, what I did is I looked at voice command usage when the user is running versus swimming. and we see something that I think will make a lot of sense to all of you. Most of the voice command usage is at least in a workout is done while running, because it's quite hard to speak into your fitness wearable or your watch while you're in the middle of a swim. We also did an average, of how many voice commands are used in a workout, and we can see that on average we do 1 voice command per run, and we do 0.08 voice commands per swim. So all pretty interesting data, which tells us that we should keep optimizing the running use case and not think too much about the swimming use case. It would have been interesting to see the opposite of what we assumed. Scrolling down further, we start looking at the intersection of reliability data or performance data with usage data. So we've always been tracking battery life for these products. It's one of our key performance indicators. And so here we have a chart of the median battery life. And you can see a drop on between June 13th and June 14th. And that happens to be when we shipped our voice commands. So we went from about 80 hours of battery life down to 78 hours of battery life. So that's about 2 hours of battery life that we lost due to voice commands. I think that can be expected, right? Voice commands require sending more data over BLE. It requires having the mic be on, probably writing more data to flash. There's going to be a trade-off, but now we know that in real world usage, that trade-off is 2 hours. Likely is okay, though we'll look at the distribution to see if there is something that we need to investigate later. The other thing that we looked at is how does the battery life change based on usage? So we know, for example, that here, as of today, our average battery life across all uses of the device is about 74 hours. But we want to look at battery life during a workout. Do people who work out a lot, do they see a dramatic drop in battery life? And so here we see that during a workout, we have 43.8 hours of battery life. It means that if you were continuously working out with a watch due to the heart rate sensor being on or the accelerometer using a higher sampling rates, we see a battery life of 43.8 hours. Seems like you can comfortably run a marathon with your fitness wearable. So this is likely well within the range of what we'd expect. So let's actually go and create a chart to look at the distribution of that battery life. Like, what is actually the worst case? So I'll go and I'll click Create Chart at the top. I'll select a battery life chart. And what we'll do is we'll look at the percentiles. So that's the distribution of battery life so that we can see the best case users, the worst case users. And we will make it a bar chart because that's a little bit easier to see at a glance. And we'll look at our users who are working out. So in effect, we're looking at the distribution of battery life during a workout. Are there users who see very different results? So I'll press OK to save that chart. And here I have it at the bottom. And I can see, my median, which is what we saw earlier, is about 43 hours, almost 44 hours. Some users actually do really well. They have 60 hours. Maybe we should look at what those devices are doing. There might be something to learn there. At the bottom, we have users with 20 hours of battery life during a workout, which is less than half of the median. So let's go see what those devices are doing. And this is, I think, a key feature of Memfault. You can go from the very broad at the top. You can look at the fleet level data, then click on the charts and dig down into individual devices driving the trends so that we can figure out what might be going on. So I'll click on this chart. I'll be brought to the device search. And here, basically, Memfault searched all the devices in our fleet to find the ones that did a workout and saw low battery life during that workout. We see there's a few test devices. We probably hammer those in the lab. So they're likely not representative. In fact, they have the lowest battery life. But we see one device, which is on our latest firmware and is a production device that has low battery life. So let's click on it and we'll see what kind of data Memfault collected for that device. Okay. So we can see we have all of our reliability data, core dumps being collected, reboots. We can see our metric data. So for example, here, I can just look at my battery level. I can look at connectivity. We can look at CPU activity. And now we have this new data in the middle, which is this product analytics data. We call it sessions. So we see a few workout sessions and we see a few voice command sessions. And we can click on each to expand them and look at the data that's been bundled alongside just the very fact the device was doing this activity. For each session, we're collecting some battery information. We're collecting, how many steps for a workout were taken, and so on. And this really allows us with the timeline to see all of these data in context and correlate, did the battery life start going down much faster in the workout? What might have been going on? This, of course, comes with all the other data we have for the device, like what software version is it running, which hardware revision is it, when did it last phone home? All very interesting. I'll show you one last thing as we wrap up. I can go back to my device search, and this time let's go look for devices that are doing voice commands and seeing a big drop in battery life. So many of you have already seen the device search, and in the context of product analytics, we've added some new ways you can search your fleet. So I'll click on historical data and report count. So those reports are product analytics data. I'll select voice commands, and I'll say devices that saw during this time frame at least 3 voice commands and saw a battery life drop of at least 2% due to those voice commands. And we will find that there's actually a good number of these devices. There's about here 1, 2, 3, 4, 5, 6 of our production devices. And so here again, I can go click on those devices and start digging into what was this device doing. Are there any voice commands that saw a huge drop in battery, and can I correlate it to any other activity on the device? So in short, with product analytics, we've now shown that we can collect some new kinds of data about how the device is used. We can display it in a very powerful way. We can put charts together, roll-ups. We can create adoption funnels. We can look at the use of a specific feature and even look at the use of that feature relative or in conjunction with other features. And of course, because this is Memfault, we can look at reliability data and how it is impacted by specific features. This is all extremely cool stuff, and I wish I could spend more time showing you all the different ways it can be used, but I'm sure you will find some that we even haven't thought of. So I hope you found this interesting, and let's get back to our slides. Getting started with product analytics is very easy. It takes 4 simple steps. Number 1, you need to define custom sessions. Sessions are the data structure we use to model the activities you care about on the device, the units of the actions, the activities that users take on the device. Number 2, you add metrics to those activities. So, for example, during our voice commands session, we're adding number of words as a metric that's being tracked alongside it. You can use the device vitals, right? Battery, connectivity, and stability, and attach those to your sessions by default. And you can also use Memfault's custom metrics to create your own metrics. Number 3, you use the Memfault dashboard, the Memfault's web application to create dashboards and analyze the data at the fleet level and at the device level. And of course, number 4, you use our OTA to push updates and make your product better. So product analytics is really cool, but that's not all. We have a lot more to show this week. In fact, we're going to be talking about new features all week. So today we're talking about product analytics, how to understand how the product is used better. Tomorrow, we'll be talking about Memfault Quick Start, a new way to integrate Memfault on your devices that allows you to get started in minutes rather than days. This is very exciting. We've been scratching our head for 5 years, really, trying to make SDK integration as fast and easy as possible. And I think we've cracked it. On Thursday, we're going to talk about our integration with Goliath. Goliath is a platform that lets you get data from your device to the cloud really easily. And so you can route your product data over Goliath. You can also route Memfault data over Goliath. We've been working with them to make that integration really good. And I'm excited to show it off to you. And then on Friday, I'll do a live Q&A so I can answer your questions. I look forward to hearing all you've got to say, and hope to see many of you there. I cannot wait to see how you will use product analytics. We've shared it with a few customers and have been blown away by the feedback. You can learn more on our website at memfault.com/launchweek. And as I just mentioned, I'll be doing a Q&A Friday. This has been a huge effort by the team. I want to give them a big shout out because I'm so proud of the work and so impressed by how incredible these new features are. And I have to tell you, there's a lot more coming. Q3 is already shaping up to be an even more exciting quarter for the company. So stay tuned for more in the future. I hope you have an amazing start to your week, and I look forward to hearing what you have to say. Bye, everyone.